Hello, everyone, and thank you for joining us today for our tech session. I'm Jessica Jackson, your moderator. Today, our presenter will take you through introducing network programmability protocols. Edwin Owen is an award-winning Cisco instructor and DevNet professional. He has over 15 years of experience dealing with clients as a sales engineer and vice president of sales. He is certified in several Cisco certifications, including CCNP, CCNA Wireless, and CCNA Security. Edwin provides high-impact expert training in both theory and real-world examples. Without further ado, Edwin.
Thanks, Jessica, and good morning or good evening, everyone. My name is Edwin Owen, and I'm a senior instructor with Skyline, mainly teaching automation programmability type classes. So a lot of the Cisco DevNet classes. And today, and let me share my screen out here for you guys, we are going to be talking for about the next 45 minutes or so about network programmability. And this is going to be basically an introduction to network programmability. So we're not going to get extremely deep into programmability, but we are going to talk about a few things. We're going to talk about one, so what is the evolution of device management? In other words, where did we come from as a network engineer, and what are we having to change? What are we having to know different to be able to do our job? We're going to get into a few configuration management tools, or we'll get into what's known as data encoding formats, understanding REST as a architecture. What is data models? And we'll talk about, data models for a router or a switch is very similar if we wanted to describe a car. We'll get into NETCONF and RESTCONF, and then we'll close up if you guys have any questions you guys might want to ask. And then I'll hand the ball back over to Jessica. All right, so let's talk about this evolution of device management. In other words, where did we come from? Where did we start out? And we're going to look at this. This is Bob, and Bob is like most network engineers. He started with a company. And when he started with his company, the company was fairly small. And so Bob probably had, a few routers, a few switches. He had some servers he had to deal with. But, just like most of us, there's things he had to know, right? So he had to know routing protocols, maybe. So things like OSPF or EIGRP. He had to understand spanning tree, probably security policies because he didn't want his network to be hacked, maybe quality of service. How did he end up, managing these devices? Well, if you've just got a few devices, right, then normally we can do it either through the command line or we can manage it through SNMP. But what happens is over time, like most of us, Bob's network grew. So Bob's network, he went from a few routers and a few switches to maybe now multiple routers and switches and servers. And so it got a little bit harder for Bob to just log into each of these devices individually. So there's a few other things he had to learn. He had to learn things maybe like TCL, which is tool command language. Maybe he did some embedded event manager or expect scripts. But it was still fairly easy for him to manage his network. But one day, Bob woke up and his network wasn't small anymore. And this happens to a lot of us, right? As we go from just a few routers and switches that we're used to dealing with to now maybe we're dealing with hundreds of switches and multiple routers, having to deal with the cloud. The cloud now, most all of us are dealing with something in the cloud. Maybe we're dealing with containers, we're dealing with VMs that are out there. And not only that, but Bob's boss was talking about things such as market disruptors, other competitors in the marketplace and what they were doing to disrupt the marketplace to take business. And was asking Bob, exactly how agile is our business? And what Bob realized is a few things. Is one, that their network was not very agile. And what we mean by agile is how quick can you make changes to your network? And what Bob realized was, look, it takes months for us to complete a project to make a change. Whereas when we talk about disruptors in the marketplace, when we talk about your network being agile, we're talking about being able to make these changes within hours, not months. He also realized that, hey, as our network grew, it was harder to manage, and not only harder to manage, but now we were having a lot more downtime. And so there was a poll that was taken. And what they found out was, 97% of operators admitted that network outages were caused by human factor. So humans cause 97% of the network outages, whether it would be a misconfiguration that was done. 22% of unplanned outages was caused by human error, and 74% of network changes had significant impacts on the business. Now, why is that important? Well, it's important because in today's world, we know that downtime is money. And to give you an example, I worked with a company called Nissan Corporation, which most of you know as Nissan Cars. For every 15 minutes, basically for every 15 minutes that they had a line down, a network outage, they were losing roughly $250,000. So you can basically say for every hour of downtime, they were losing $1 million. So it's important nowadays that when we look at our networks, that one, we have to be able to manage them and manage them efficiently and manage them in a way that it's not causing downtime. We have to be able to make sure our networks are agile, meaning that not only are they not going down, but if we need to make changes to them, that we can make changes very quickly, where it doesn't take months for us to make a change to our network, but we can make a change in with either a few hours or maybe just a few days that are there. And we've got to do that just to stay within the marketplace and stay competitive. And so to do that, what Bob realized is, look, there's some new things that I need to know. These skills that I had, my network skills, of layer 2, layer 3 fundamentals, quality of service, security and segmentation. I still need to know those. But along with those, I need to know, hey, what are the platform skills? I need to understand cloud fundamentals. Maybe I need to understand AWS or Azure. I need to understand containers and the difference between containers and VMs. Probably need to understand some Linux. And I probably have got to learn some type of programming skills. And to understand programming skills, we're talking about things like data formats, things like JSON or XML. We're talking about some language. Python is probably the best one to learn from a network engineering standpoint. It's easy to learn. It's has a very large community, especially in the network engineering area. And so a lot of the things that you're going to do within network engineering, you can probably pretty much find already written out there. Things like Python, you need to understand APIs. Might need to understand stuff like JavaScript. You're probably going to have to understand Git from version control systems so that you can manage your applications, make sure they're the right version, and not only applications, but manage configuration files. And making sure, especially if you're going to get into using configuration files to manage or set up your network, you want to make sure that you've got those versioned. And then you probably want to know some type of configuration management, those being something like Ansible or Puppet. And so if we look at kind of some of the things that you probably want to learn, right? Some of the different things that Bob probably needed to sit down and start trying to learn to be able to automate his network. One being, if you learn Python, with Python, you can then use libraries like NetMiko, and you can write applications. And this is a very good place to start, right? When we think about something like a language like Python and using a library like NetMiko, well, if I just learn a little bit of Python, the NetMiko library allows me to make an SSH connection to my device, and then I can send commands to my device, right? So really with just a little bit of learning of a language, you can start automating your network. You can use some configuration management tool, Ansible, Puppet, SaltStack, Chef. Those are the four main ones that are out there. You might want to start learning something like REST APIs. And then you also probably start learning things like RESTCONF, NETCONF, gRPC. Those are what we call model-driven APIs. Where are you going to start? It really depends, right? So it kind of depends on what your knowledge is and what you have within your organization. So again, a lot of people will start with Python. They'll start using some library like NetMiko. They'll go from there. Maybe they start learning about REST, the REST architecture, which we get into. They start learning about configuration management tools, maybe using Ansible, which is a popular one for networks. And then probably the last thing you step into is more of the RESTCONF, NetConf, gRPC, just because they're a little bit more complex to learn than REST or using Python with NetMiko, right? So what we're going to do is we're going to take a look at just a few of these things. We're going to look at a couple of configuration management tools, talk about the difference between those. We will talk a little bit about REST. We'll talk about some data formats that are out there, the difference between RESTCONF and NETCONF, and data models. All right, so from a configuration management tool standpoint, the two main ones you're probably going to run into are Puppet and Ansible. Biggest difference, well, it's quite a few differences between the two. If we look at Puppet first, normally Puppet you're going to see used with servers. It has a very limited network device capability that it can configure. It is written in basically Ruby is the language. Created around 2005, it has what's known as, the way you write it is what's known as a declarative manner. Declarative meaning that if I want to make a change to a server, I don't have to tell it step by step what to do. That would be procedural. A declarative manner means I just need to tell it what I want the outcome to be. I want it to load some application. I don't have to tell it how to do it, right? So a declarative manner means I just basically tell it what the outcome is, and it goes and it does what I want it to do. The reason why it doesn't have a lot of network device capability is because it's what we call agent-based, meaning that you have to have an agent on the device. And the way that it works from a high level is about every 30 minutes, the agent node runs. So the agent that's on, say, the server will run, and it will contact the master server. And it basically asks the master, it says, hey, tell me what my configuration should be. And the master compiles together what's known as a catalog. And the catalog is made up of what we call manifest. Manifest, you can think of, is a configuration file that describes how to configure one aspect of a resource. If I take a bunch of manifest and put them together in a catalog, it describes the complete configuration of that resource or node, as we might call it. So the master actually puts together all the manifest into a catalog. It sends it back to the agent that's running on the server. The server then takes it, looks or checks the state of its configuration, and then it makes changes to the resources to make sure that it matches the catalog that's been sent to it. All right, so that's kind of how Puppet works. The other one that you will run into is what's known as Ansible. Ansible, you'll see a lot more being used in networks. It was created in 2012. It was acquired by Red Hat in 2015. Its management system is more of a hybrid manner, meaning that it can be procedural or it can be basically declarative. And it's basically depends on how you run it, right? So if I run it from the command line, just commands, it can be procedural. If I make playbooks out of it, a playbook is kind of like a catalog in Puppet, right? So the way that Ansible works is we have what's called a playbook, and inside that playbook, we have what's called plays. And those plays are made up of modules. And the module describes something that needs to be changed, right? And those modules, you can actually download the majority of those modules from Ansible, or you can make your own modules if you wanted to. It is agentless, which is why it's used with networks, network devices. So I don't have to have anything on my network devices for this to work. So it's basically known as a push model. So basically the master will push these configuration changes out to the network devices. Whereas when we think about Puppet, which we just talked about, it is known more of a pull model. In other words, the agent is pulling the configuration from the master that's there. So those are the two, when we think about configuration management tools, those are really the two that you will run into probably the most out there. One of the things that you will need to know as you get into automating your network with programmability is what's known as data encoding formats. Now, the question is, why do we need to encode data? And the answer to that is, if we think about having two devices, maybe I've got a network device, a switch, or a router that's out there, and I've got some application, maybe I've written an application in Python that's running on my computer. If I've got an application and I want to send configuration data to my network device, I need to put it in a format so that when it gets to the network device understands how to read that format, right? So it understands the information that's coming to it. Same thing, if the network device is going to send information back to my application, it needs to be basically in a format, needs to be encoded into a format so that my application understands how to what we call parse it. And when we look at sending encoded data from a Python program to a network device. So for example, I might have an object in Python, and that object might be a name. I need to take that name and I need to put it in some format, say for example, maybe JSON. Now, when we do that, when we take an object in an application and we put it into a format like JSON, that's known as serialization, right? So, and then that JSON file can be sent to the network device, and the network device can actually read it. When we go the other way, when we have a file, JSON file, and we actually want to turn it into an object or turn it into something that, whether it be my Python program can understand or a network device can understand, that's known as parsing. So going from, say, an object in a Python program to changing it into a format would be serialization. Going from that format back into an object would be what we call parsing. And there are multiple different languages or basically formats you can use. The first one that came about was what was known as XML, which is Extensible markup language. It was really the first format that was both human readable and machine readable. Came about in around 1998. Its extension is a .xml. It works on a opening and closing tag. And white spaces may or may not be important. And if you look at it here on the right-hand side, this is very similar to what XML would look like. You can see it gives me at the very top the declarative statement. So I've got my version number, and then I've got these opening and closing tags such as number, right, or type. And you'll notice that I open with number and I close with basically a / number. Those have to match. So when we talk about opening and closing tags must match, those must match exactly. In other words, a capital N on number and a lowercase n on number are not the same thing. Where does white spaces may or may not be important? White spaces within inside the tag are important, right? So if I do last space name or last name with no space, that's different, right? So that space matters. Sometimes spaces within the data itself might not matter. Depends, right? Spaces here where we have on, see if I can grab a little laser pointer here. But all of this that is here, all this white space does not matter, right? So just some things to keep in mind about XML. Open and closing tags, they must match. White spaces may or may not be important depending on where they are. And the information or the values that are between the tag can be strings, numbers, lists, booleans. The other one, and this came along after XML, is what's known as JSON. JSON stands for JavaScript Object Notation. Its extension is the .json. It uses what's known as objects and arrays. So objects are basically between little curly brackets. Arrays, or basically think of an array as a list, is between square brackets. Again, it is human readable and machine readable. White spaces here are insignificant. So if you look at the white spaces that are basically the indentions, those do not matter. It makes it easy for us to read with those white spaces, but we could put all of this on one big long line and it would still work, right? It understands everything based on the curly brackets and the square brackets. It has everything is in a key value format. So for example, if I look at train, the key might be date, and then the value would be 7/4/2016. The key is basically surrounded by double quotes. And then of course your value it could be a Boolean, it could be an integer or a float, or it could be a string. Everything is separated by commas except for the very last value of each object. That's where a lot of people will, and there's a lot of tools out that are on the internet that you can actually take and validate your JSON just to make sure it's correct. But a lot of times where a lot of people will make a mistake is they put commas at the end of everything, and you just don't need it at the end of everything. You need it at the end of everything except for the very last value that is within each object. One of the things that you will hear within automation and programmability is what's known as REST. REST stands for Representational State Transfer. It was proposed by Roy Fielding in 2000, and the key thing to know about REST, it is not a protocol. It is an architecture. It is an architecture that describes if your API is going to be RESTful, what is considered RESTful, there are some constraints that it has to meet. Some of those constraints being that it should be a client-server type model. They should be separate. In other words, you should be able to change the application that's on the client side and it would not affect anything that's on the server or the network side. It should be able to go through multiple layers of your network and not have any issues with it. So there are about 7 roughly constraints that for your API to be what's considered RESTful that it has to meet. The great thing about REST is it's pretty simple. It deals with the things that we deal with on a daily basis. In other words, the protocol it uses is HTTP. So you're going to be using HTTP and you're going to be using a URL that will actually access the network device or the resource on that network device that you're wanting to change. It uses what's known as the simple CRUD model. In other words, create, read, update, and delete. We'll talk about that in just a minute. But basically, we have what's known as methods or verbs, and those are what we can do with that resource. It is a stateless client-server model, meaning that it does not build a state. Everything that has to be sent for that resource, if I'm changing that resource or if I'm just getting the information in that resource, has to be sent all within one request. I can't send multiple requests for the information. If I want to get information about a interface, it all has to go in that one request, and then I will get a response back for that. And the URIs are used to identify the resource. Now, how does REST work? Well, it works on what's known as a request response. So from a request response, we have in the request, you'll have, as mentioned, the verb, or basically the verb, we also call it a method. You'll have the URI, which is the location of the resource that we're either getting or changing. You can have the version. And then we've got what's known as request headers and a request message. So request headers are going to be things such as the format that the data is being sent in. It could be the format that we will accept data back in. It could be authentication that we're using could be sent there. There's a list of different headers, request headers that can be sent, whether or not it can be compressed or not. The request message, there's only going to be really a message if we're making changes, right? If I'm getting something, if I am requesting information, then I'm not going to have a request message, right? But if I'm changing, say, the IP address of an interface, then what I'm changing, that IP address would be in the request message. What comes back to me is a response. And that will have a response code. It's going to have things like the version. It's going to have response headers in it. And it will have your response message. The response message could be, it could be if I am getting information or requesting information, the information I am requesting will come back in that response message. If I am just configuring something, then normally I don't get a response message back. I normally get a response code that tells me the configuration happened okay. So I might get something like a 201 or something, but I normally don't necessarily get a message back. Now, if we look at the different verbs or different methods that are available to us and different response codes, the different methods that you can use are things like get. So a get would be, I'm trying to read a resource. It could be post, which means I'm basically creating a new resource, or I am changing a resource. Put, replace a resource. Patch, modify a resource. Delete would remove a resource. The key thing that I tell people when it comes to verbs or methods is that when you are dealing with APIs, you're going to have API documentation. Always read your API documentation to understand what methods or verbs that the resource will accept, because not all resources accept all methods and verbs. And to make sure you understand exactly what those methods or verbs do, so that you can understand they might not be exactly like this, but they'll be pretty close. The other thing that you should understand is on the response codes, what are the different responses that you can get back? So normally if it begins with a 1, it is informational. You don't see those a whole lot. If it begins with a 2, that means it was successful. In other words, a 200 means okay. A 201 means that a resource was created. 204 means no content, right? So 400s, anything begins with a 4 is a client error, meaning 400 could be a bad request. We see that a lot of times when we're trying to access web pages. A 401 could be unauthorized, meaning authentication is bad. 403 would be forbidden, meaning that you don't have rights to do whatever it is you're trying to do. Maybe you're trying to delete something, right? You don't have access to or rights to that resource. 404 is not found. 429 is too many requests. Those are the main ones you'll see a lot. 500s is a server error. Those could be internal server errors, which is a 500. which is basically kind of a general type error. 503 means the service is not available. So maybe the service is down or a service can't respond for some reason, right? In REST, well, let's step back. I mentioned earlier, and when I was talking about Python, that you could use the programming language Python with a library called NetMiko. And what NetMiko does is NetMiko actually makes an SSH connection to your device, and then it allows you to send show or configuration commands to that device. And that's great when you're starting out. The problem with that is that when we think about automation, if I'm trying to automate things, I want to make it as easy as possible. And if I'm having to send show commands and configuration commands, then the problem comes in if I've got a multi-vendor environment, then that means I need to understand all the show commands and all the configuration commands for all the vendors that I have. It would be a lot easier if I didn't care what those commands were. In other words, if I just wanted to change something and I didn't have to know what the configuration command was to change that, I could just say, hey, go change this interface, and it would make that change. And this is where data models come in. So what is a data model? The best way to describe a data model is to basically say it's kind of like the model of let's say a car, right? So if I was going to describe a car to somebody, then what could we say? Well, we know that a car has an engine, right? It could be a four-cylinder, it could be a V6, V8. We know that a car has a color. We know that a car has doors, could be two-door, could be four-door. We know that cars have seats, could be leather seats, cloth seats, could be how many, what type of seats do we have within the car itself? Does it have air conditioner? I hope so. Does it have heated seats within it? Does it have cooled seats? And so when we think about that, we can build this model that describes a car. We can actually do the same thing with network devices. So we know that when it comes to network devices, that there's going to be certain things that are common within all network devices, right? So let's take a router, for example. A router is going to have a host name. It doesn't really matter what vendor the router is. It's going to have a host name. It's going to have IP addresses within its interfaces. It's going to have a subnet mask within its interfaces. It's going to have routing protocols that it uses. Now, while some are general information that all devices have, some could be vendor specific, some could be platform specific. So for example, we know that EIGRP is only going to be on Cisco devices, where OSPF is among all devices, right? Because it's open. So EIGRP would be more of a Cisco common type of configuration. Platform specific would be very specific to a platform. So it wouldn't be within all Cisco platforms, but it would be very specific to that platform. So if we know what all of these are, and we have this model, then it's a lot easier for me to make changes to my devices, because now I don't have to know show commands or configuration commands to get the information I want. So what a data model does is a data model describes a constraint set of data. So if you think about it, it's a standardized representation of data within your network device. It does not send any data at all. So it's not responsible for sending data. It is responsible for describing data. It can be used for validating a configuration, When we think about the language that we're going to make these models in, Yang is what we call yet another next generation, is a language that we can use to basically describe our data or our model within. And there are a lot of different devices that have data models. So your Nexus 9000, 3000s, ACIs, DNA Center, all those have data models. So I mentioned Yang. What is Yang? Well, Yang is what's known as yet another next generation. It is described in RFC 6020. It is protocol independent, so you can use it with NETCONF, you can use it with RESTCONF, you can use it with basically gRPC. It describes configurational, operational, and RPC data. It provides semantics to better define the data, and it's extensible and modular. And here's the thing with it, right, is that what it allows you to do is it defines things such as host name. So, for example, a host name on a router, it defines that it is a string. For an interface, it will define what an IP address on an interface should look like. Not only that, but it will also define what the range of that IP address can be. So if you try to do something like, if you try to put 500 into an IP address, it will kick back and say, hey, this isn't valid, right? This does not fall within the range of what is defined within the data model, right? And so therefore, it won't even try to configure the device. So it puts these constraints around it of, okay, is what we're trying to configure a string? Is it a integer? Is it a Boolean? Is it a float? What is the range that it can be in? Maybe if we're talking about VLANs, then we can have a VLAN say, hey, we can have VLAN 1 through VLAN 1000. If we try to do something outside of 1000, then it would kick back to us. Those are what data models are used for, and it's used within NETCONF and RESTCONF. And so what is NETCONF and RESTCONF? Well, NETCONF is what's known as a next generation network management protocol. Why did they come out with NETCONF? Well, believe it or not, SNMP, most of us in networking use SNMP to get information, traps, things of that nature. But SNMP could also, it was designed to be used to configure devices. Although I don't know anybody that uses it to configure devices. The reason why is because, one, if you've ever tried to deal with a MIB table, they're not the easiest thing in the world to understand. Two, SNMP did not allow for configuration of everything that was on a network device. Three, it was very complicated to try to use within programming, right? So when they came out with NETCONF, the idea was these engineers got together and said, hey, we need a new way of basically network management. And they came out with NETCONF. And NETCONF is it's a client server model. It uses SSH as the transport. It deals with what's known as configuration and state data. So state data is data if we're getting information, configuration if we're changing the information. It has different what they call data stores. It has what's known as a candidate, a running, and a startup. So if you think about the running data store would be like your running config. The startup data store would be like your startup config. The candidate is kind of like a workspace, right? In other words, it's a place that I can make configuration changes first, and then I can basically push that configuration change to my running if I wanted to. It does provide client-side configuration validation. It's not the first thing you're probably going to start out with when you're dealing with programmability. It's going to take some time to learn NETCONF and understand Yang and the data models that are out there. But it is supported by the majority of the Cisco devices, your 9000s, your 3000s, I think. So those type of devices. And if we look at their protocol stack, it uses the messaging that it uses as RPC. The operations that it uses, or if you think about operations, is kind of like within REST, the methods are verbs, right? So we get things like get config, copy config, commit, validate, lock, unlock, those type of things. The content is in XML format, and it uses Yang data models in the XML format. And the transport that it uses is SSH version 2, TLS, or SOAP, normally SSH version 2. Again, it's probably not going to be the first thing that you start out with, but considering that it uses data models, it makes it a lot easier to use these models than it does to have to learn every shell and configuration command that is out there. Now, the other one that's out there is what's known as RESTCONF. And the question you get a lot is, look, if I have NETCONF, why the crap do I need RESTCONF? Matter of fact, RESTCONF doesn't do everything that NETCONF does. It doesn't have all the data stores, so there's some limitations to it. The reason why that RESTCONF came out was because most people are used to using REST. Again, REST uses a URI to access a resource. It uses the HTTP protocol. It uses a method or verb such as get, post, put. And these are things that, from a programmability standpoint, most people are used to using on a daily basis. NETCONF, I said, was completely different, right? So NETCONF is going to take some time to learn. So what they did is they said, look, if we can put these two together, it makes it a lot easier to make that transition. And so the great thing about it is it's still based on a model, your Yang data models. Not only can you use XML, but you can use JSON. A lot of people like using JSON more than XML. You don't have to use SSH, you can use HTTP. And if we look at the protocol stack, from a transport protocol, it's HTTP, content is going to be XML, JSON, and then your operations are things like get, post, put, patch, and delete. So again, a lot easier to make that transition to, right? So I don't have to completely learn a new protocol. I can actually learn a protocol that's using the REST architecture with it, along with some of the ability that NETCONF has.